A good 5-minute notes. All right, I don't have it up on the screen. You just got to stay with me here. We got kind of a funky looking piece of paper with a big gap, so we're just gonna go down to the box, okay? It says right angle trig applications, which basically just means word problems, or a problem that doesn't just give you a triangle, a problem where you might have to draw a triangle, okay? We have two things, the angle of blank and the angle of blank. One of them, the angle of, is an angle formed by the horizontal line of sight when looking up. So at the end there, when we are looking up, and think about it, if you want to draw maybe a little sketch right above that, think about it when you're looking, and then you're looking up. Like maybe you are watching a plane fly through the sky, or maybe you are looking up to the top of a lighthouse, or anything like that. Those are the silly type of problems we'll be doing. This is called the angle of elevation, which isn't a strictly math word. We've heard that plenty of times when it comes to mountains and when all kinds of different stuff. Now, what do we call it? Zoom time. When we are looking down.
De-elevation?
That is not a bad guess.
Angle of depression.
Yes, it is. Back to Hannes again, huh? The angle of depression. And the angle of depression just means you're looking downwards. And the real way that I like to think about this is always start by thinking about the horizontal line. Start by thinking what happens if you look straight ahead. Once you find that, okay, there's the look up, there's the look down, and you can sort it out. So the next picture, which is really kind of crazy looking, is a guy on a cliff, and there's a bunch of lines. Let me use green here. There's a line that goes straight out, there's a line that goes up, and then over here there's a helicopter, or it's actually a plane, not a helicopter at all. There's a plane, and there's a line that goes like that, there's a line that goes down here, and down here there's a motorcycle. Okay, this makes sense. There's a boat down there. So, these lines have little angles in there. We got angle 1, and angle 2, and angle 3. And this one, angle 4. I always like to think about find that horizontal line, and then where does your other line go? So for angle 1, is this in horizontally, then looking up? That would be elevation, or horizontally and then looking down, depression.
Depression.
Right. 1, we've got depression. But we'll get through it. For number 2, horizontally and then elevation. Then we look up, elevation. And then 3, horizontally, depression. And then 4, horizontally, elevation. Obviously, you don't, some of us, this will just come really naturally. And we can look at an angle, and then, oh my God, that's elevation. Oh my God, that's depression. And we can do it in 2 seconds. Some of us, I don't know, maybe this gets a little tricky. And I'll be honest, this is not something that I can look at this and instantly 1 second go, depression, elevation, done. I think about it for a second. I say, okay, horizontally down, that's depression. Now, we are going to do an example, the one on the bottom of this sheet. It says, a surveyor is 980 feet, that's going to be important, I'll just write that down, from the base of the world's tallest fountain in Fountain Hills, Arizona. Strange. His measuring device is the same level as the base of the fountain. Okay, cool. Using this device, he finds that the angle of elevation to the top of the fountain is 29.7 degrees. What is the height of the fountain? We want to take all that and real simple. We want a triangle. Right? We're doing triangles. We're not doing squares. We're not doing anything funky. What do you think is the, if if we think about this being the ground, what is the tall, long line that is the height here going to be? Well, before we give it a number, let's give it, what is it in real life? Or what is it in this problem? This is going to be the fountain, right? And in fact, they're talking about like a fountain that shoots up water, which is silly, but Fountain Hills is a park with these giant fountains that shoot them up super high. So this is going to be the fountain height. What is this along the ground? What does this line represent? So it's not, it is the base of the triangle, but in real life, this is the distance from the base of the fountain, which is at the corner, shooting water up, and the guy or girl, can't remember if it says that it's just a surveyor, it could be it. Here, we'll give her some nice cute hairs. So that's just the distance between those two things. And as always, it's a triangle question. We get two numbers and we're missing a third. So one number they gave us is 980 feet. It says that the surveyor is 980 feet from the base of the fountain. Is that going with the height or the distance? That's the distance, 980. Then it says, blah, 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 blah. 29.7 is the angle of elevation. So that's an angle. Is that going here with A or is that going here with B? It's going with B, 29.7. And now, we've got a triangle with two pieces. We could find the whole triangle if we wanted, but we don't want. We want one thing in particular, which is, what is the height of the fountain? Now, we're going to lunch as soon as we set up a little function here. Are we using sine, cosine, tangent? We're working with opposite and adjacent, so we definitely want tangent. We need three things. The tangent of the angle, 29.7, the opposite, which is x, and the adjacent, which is 980. Is there any new math here? No, but we got a whole paragraph we got to read. That's where all the difficulty comes from. Lunchtime, when we get back, we do some problems. Nice job.